Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we have seen a lot of the theory and a few worked examples on how dummy works and also how interaction works. What is the extra information that they tell us? In this video, we're going to look at an application in R. So let's switch to R and see the example. We're going to use already available data sets from Wooldridge. So the data set that we're going to use for this video is wage 2. You'll have to install the Wooldridge package so that you can make use of the data sets. So you'll have to do that through install packages and obviously install the applicable libraries. In this case, they're going to be Wooldridge and ggplot because we're going to also show graphically how exactly that beta 3 is giving us that extra information that we need about how a certain variable might be affecting the outcome variable through another variable. So looking again at that marginal effect concept. So the data is wage 2, and we can have a very quick look at how that data works right in here. So we've got wage, hours, IQ, education, and experience, which are very important. And what we have mentioned quite a lot in our worked examples together. We've got age, we've got married, which is one of the variables we're going to concentrate in this video. And in another video, which we're going to see next, there's also ln wage in case we need to look into the log version. You can have a further look into what kind of variables you have by looking more intently to like wage, for instance, is an integer variable, so is hours. But while, for instance, married is also an integer, the values go 1, 1, 1, and you've got a 0, so that is a dummy variable. And that's why I said this is one of the variables we're going to concentrate on. For the first model, we're going to see dummy and continuous interaction. So the question being, does education pay off more for married individuals? And the model in here is wage, beta 0, beta 1 education, beta 2 married, and the interaction is that between education and married. So the model is pretty straightforward, and you can see in here the new item that we have added in here is this education column married, and that is exactly what is creating that interaction term that we need. So if we run the model and then look at the summary, we're going to see the actual results of the regression in here. We've got education, for instance, 42.17, and we see the p-value in here with a 1 star, which based on the significant level codes in here is significant at the 10%. And then we've got married and at the 5%. And then we've got education and married in here, which is the interaction. Unfortunately, it doesn't have a star in here, so it does mean that actually the interaction term here is not statistically significant per se. Keep in mind, when you are running this regression in here where you're using education column married, this is one of the ways you can add the interaction term. In R, you can also add it by writing actually education times married. What is always important to remember is that you always need to include the constituent terms. So you can never run this regression, let's say just wage tilde education married alone. So in here, you'll always have to add education and married separately as well on top of the interaction term. This is important to remember because when we move on to the other videos with Stata, we're going to see that different rules will apply depending on the kind of method in which you introduce an interaction term in Stata. Okay, so for this case, we knew that the education times married in here, that's our interaction term, and that is like the extra return to education that is related to being married. Let's compute the marginal effects because manually, because we have done already a lot of exercises in the previous videos where we have seen, for instance, what is the effect, let's say, of education, depending on the different level, for instance, of training and so on. So in this case, let's look at the marginal effects manually. So we're going to save the betas from the model for education and also the interaction, so both the beta 1 and the beta 3. If we find the marginal effects, keep in mind that we're always looking at the derivative. So if we look at the derivative of wage with respect to education, clearly that is beta 1 plus beta 3 times merit. So as the case by case we've done, if we are married, it means that merit is equal to 1, in which case the total effect is beta 1 plus beta 3, while if we are married, then the merit is, if we are not married, merit is 0, so the effect will be simply beta 1. Okay, so let's save all of these effects based on this model, and we can now see, by running these 3 codes in here, the actual effect for education for unmarried, married, and the difference. This is, again, using the same information. So this information we could have gotten based on the theory by now, just on the results that we had in here. But let's match these numbers to the actual computation. So if you see, we knew that the effect of education for the unmarried would have been simply the beta 1. The beta 1 we knew from the regression is this 42.17, which is exactly what we see in here. Then the effect of education for marriage should have been beta 1 plus beta 3. We had beta 1 in here and beta 3 in here. So if it is the sum, it should be 64, which is exactly what we get in here. And then ultimately we have the difference, which should have been the beta 3, and indeed here it coincides exactly with 22.17, which was the beta 3 that we got into the actual regression. So what we have just done in this step is a little bit all of the steps that we have done in the calculation exercises together, which is going through a step-by-step routine. We write the marginal effect, we plug in the values, and then we do the interpretation. So in here, based on the results that we have in here, it would seem that, well, it's the actual beta 3 is not statistically significant. So normally we shouldn't really be seeing any difference or any additional difference on like the effect of being married and educated bring to wages. Now, let's see the two fitted lines side by side, just so that we can get a better idea of like visually what's happening with this case. So for fitting the two lines, we're going to, first of all, predict the model. So we're going to create the fitted values from the regression model, store them as a new column in the data set, and then the code will create basically a range of education values. So this is what creates that range of education values. It's going to give basically 100 evenly spaced education values between the minimum and the maximum education values that it's going to look through the data set. And then the two blocks in here that we got for the prediction, these are just like new hypothetical data sets that are being created with these predictions, where in one of them everyone is unmarried and in the other everyone is married, and then education varies smoothly into both of them. Then the model will be used to predict the wages for each of those cases, so that then ultimately we can use the predictions, or like these two prediction data sets, and visually see the two fitted lines, one for the married individuals and one for the unmarried individuals. And if the lines have different slopes, then visually that will show that the return to education differs by marital status. Okay, so let's run all of these code at once, now that we know what the whole purpose is. So this is creating all of the values that we need in the two hypothetical data sets. The ggplot in here is going to help us see the two lines. So as we can see in here, the two lines don't really look as parallel. Okay, so it means that the interaction is actually doing something. If they were parallel, beta 3 would have had to be 0. So it means that actually there is a difference on how this effect of education and marital status is affecting the wage. The other example that we can see here using exactly the same reasoning is by looking into a continuous and continuous interaction. The model in here is, instead of using merit, we're going to use education and experience, which is something that we have seen also in the worked examples. I'm just going to go ahead and run these code, since this is exactly the same kind of reasoning that we have used so far. The only thing in here that will be different from the previous case is that now that we have a continuous model, it means that we don't no longer look at just like two separate hypothetical data sets, but we are looking, we'll have to look into actual values that we need to plug in terms of like experience. And that's why in line 91 in here, we've got like experience values 0, 5, 10, 15, and 20, which will be used when we compute the different values. So for instance, in here, depending on experience, so we've got the 0, the marginal effect of education is 35. When the experience is 5, then the marginal is 54. When 10 is 74, and so on. Because keep in mind, the derivative in here of the marginal effect should have been beta 1 plus beta 3 times the experience values. So of course, depending then on the experience value in here, we will get a different marginal effect, which obviously is dictated by that beta 3. If then we continue to plot the lines, the family of lines for these continuous, because for every single line now we will, or value of experience, we can now see a different fitted line, which is exactly what we are going to do with this next group in here. You don't need to look too much into like what exactly this code is doing, because that's not the point. So I'm just going to go ahead and run it just so that we can see ultimately the different values in here. So we did the computations based on like 0 years of experience, 5, 10, and 15 and 20. Here we've just taken out the 15 and just shown 0, 5, 10, and 20, so that you can really see that the higher the experience in here, the steeper this fitted line becomes, because based on the marginal effect, now a higher level of experience is going to give us like a higher number when it's multiplied with the beta 3, which is something that we've seen in the previous videos, the theoretical videos as well. Okay, so this is the continuous interaction visualized, because compared to the previous dummy continuous case, you can no longer look at just like two hypothetical cases. Now you have to apply the actual different values. For each of the values now, you'll have to see an actual fitted line. So overall, what you have to understand is that in R, interaction terms are created basically with the colon operator. You'll always have to include the constituent terms. You have to evaluate marginal effects at meaningful values, just as we have visualized with the step-by-step procedures in the previous videos. And most of the times, to make the point, it's always useful to see a graphical presentation. And as you saw in these two cases, for the continuous case, we have to go a step further by plugging different values for experience, since now the actual marginal effect is beta 1 plus beta 3 times experience, right? In the next video, we'll do the same for log models and see how elasticities vary across the individuals. So stay tuned, and I'll see you in the next video.